Hello, and thank you for joining us today for our webinar, Friction, Fraud, and Trust, Addressing Consumer Demands Through Machine Learning. We are going to get started in just a few moments. I'm going to give folks a few minutes to get settled. So just please hang on the line and we will get started shortly. Thank you for joining us today for our presentation. We are going to get started in just a few moments. Please stay on the line and we will begin shortly. Hello, my name is DJ Murphy. I am the editor-in-chief of Card Not Present. I want to thank you for joining us today. Our presentation today will be Friction, Fraud, and Trust, Addressing Consumer Demands Through Machine Learning. I just wanted to say off the top that to everybody who's joining us today, thank you so very much. I know normally most of you would be sitting at your desks for a presentation like this, but as we keep being reminded, nothing is really normal right now. So wherever you're sitting, I want to thank you for making the effort to be here today. It really means a lot to all of us. As I'm sure you've read in recent weeks, and I know we've been covering it in Card Not Present, while some e-commerce verticals are hurting really badly, airline, travel, and some others, because so much of the world is under stay-at-home directives, a lot of online businesses are actually surging at this point. And one thing we are seeing, and we have reported on, is that fraudsters are definitely taking advantage. They are not remaining inactive at this point. The increased volume is actually good for them, and we see evidence that that fraud is surging right alongside the increased volume. And at the same time, consumers still have very high expectations of their online experience. So today we have Beth Shulkin and Matt Gonzalez. They're both from Ekata. Beth is Vice President of Global Marketing, and Matt is the Senior Product Manager. They are here to talk to you about how to build trust with consumers and what they expect from their online experience and the security of it. They'll take you through their presentation shortly. I'd just like to say they will be answering questions, so please do feel free to ask questions under the questions tab in your webinar dashboard. They'll take them at the end, but you don't have to wait till the end to submit questions. You can submit them at any time. Also, we will be recording the webinar, so if you do miss any of it, if you have to step away or whatever, the presentation will be available on Card Not Present after the event. We will send an email out to folks who signed up for the webinar when it does become available. So at this point, I would love to turn it over to Beth, and Beth can take us through the presentation.
Great. Hi, thank you, DJ. So as he said, I'm Beth Shulkin. I run marketing for Ekata. And today we're going to talk about friction, fraud, and trust and how to address a lot of these consumer demands through machine learning.
And I am Matt Gonzalez, product manager here at Ekata. My day-to-day job involves working very closely with our data science team, driving all of our machine learning-based products and initiatives.
Great. So for those of you who may not know who Ekata is, we are a digital identity verification data company. We basically leverage name, address, phone, IP, looking to basically help companies like yourselves with improving transaction authorizations, combating cyber fraud, and enabling a frictionless customer experience. So today we're going to talk about some research that we actually commissioned, kind of the interplay between friction, trust, and lost revenue. And then Matt's going to spend a good portion of time talking about data and machine learning and how this can help folks like yourself actually affect the consumer experience. So this is probably not news to many of you, but our lives have moved online, and even before COVID-19 reared its ugly head. The growth in e-commerce was expected to exponentially grow over the next 5 years. We're going to, I think, see this even more as people now are spending more time at home, aren't able to shop, aren't able to eat out. And so I think this is actually going to have a larger ripple effect about how consumers embrace digital. One of the things, as DJ mentioned, we work with e-commerce companies, marketplace companies, payments companies, fintech companies. And so we have a broad global network, and we're seeing in our data as well that there's an uptick in e-commerce, there's an uptick in a lot of delivery services and marketplaces, whereas there's decreases in travel and hospitality and dating and things like that that require kind of that personal touch. And so some of the research that we're going to go into here in a little bit is really about the rise in consumer expectations. So we kind of like this graphic just to talk about how folks, have increased their expectations because of the advancements in technology and digital. And we're seeing this even more. So I went online yesterday to order something off Amazon, and it was like 2 weeks was the estimated shipping date. And I was like, whoa, right? I'm so used to having things instantly delivered, having same day delivery or next day delivery. And I think that's kind of this impact of COVID-19 is because there's reduction in workforce, because there's an uptick in the number of people that are ordering. I think we're gonna, like I said, see that ripple effect. I'm assuming Netflix is booming because I've got a couple teenagers and I'm pretty sure they've watched every series that's available. So again, just we have this technology, this power at our fingertips to do everything digitally. And I think we're just going to see that continue to grow, which also means fraud grows, right? The more things move online, the bigger it gets, the more volume, the more fraudsters are going to take advantage. And quite frankly, the more companies like yourselves and us have to help protect our consumers from fraud, protect our businesses from fraud, and help our good customers get what they need. So this is one of the reasons that we commissioned Vance & Bourne to conduct our market research. There is a full research white paper. We'll make sure you guys have the link after that so you can view the full research if you haven't. But basically what we did is we looked across not just North America, but also in Europe. We looked at the Netherlands, France, Germany, the UK. We interviewed about 7,000 consumers to talk about a couple key areas. Now, the other thing we did that's not necessarily in here, but it is in the white paper, is we did a qualitative set of research with e-commerce companies, marketplace companies, fintech companies about how they're viewing their customer experience and supporting customers and fighting fraud. And so just some really interesting insights that came up. So key areas that came out of the research are importance of trust, probably not that surprising, right? As we move things online, you have to build trust in a different way. The concerns about fraud for consumers, and then ultimately the frustration that they face with friction in their digital lives. So first, importance of trust. This is probably not surprising, but does trust really matter? 98% obviously say trust is extremely important to their digital experience. And then we looked at, is that growing, right? Is that just always been, or is that something that's changing as our lives have become more digital? And 92% of the respondents said trust is an issue that's becoming increasingly important for them because they're doing more and more things online, because we're operating more in a faceless world. And then one of the things we wanted to do with the research is actually look at, is it different for age groups, right? So are these younger generations that are now becoming more of the buying power, do they have a different experience because they've grown up on digital? And I was kind of surprised that, and we'll see some of these age charts throughout the research, that millennials actually do value trust and reduced friction and security and data privacy nearly as highly as some of the older generations, which just means as those groups become more and more of the buying power as our younger generation, that 15 to 24, continues to go into the workforce. I think that'll become even more important. So how does this relate to fraud? Concerns about identity fraud. So 70% said they're very to extremely concerned about being victims of fraud. 90% say that they're somewhat, too extremely concerned about being victims of fraud. And again, this was another one that I found really interesting by the age cut, because I thought younger generations would potentially not feel that way, right? They're more free giving of their data and information because they've grown up in a digital world, right? Everything that they do is on their devices, and they're more willing to set up applications and open up accounts, and so they can leverage, all the different digital apps. But clearly, they're concerned about still having their identity stolen and fraud. So this means, right, that as businesses, we need to continue to combat fraud and help them feel more secure. So what are the impacts of fraud on consumer behavior? Probably not surprising to some of you, but they're going to post negative feedback. The chart you're looking at basically has from extremely likely is the dark purple down to red is kind of I don't know. But obviously you're looking at large percentages, 70 plus, 80% are extremely very or somewhat likely to do this when they've experienced fraud on your platform or with your company. And really the top two, posting negative information or telling other consumers about fraudulent activity, that's good feedback, right? Because that allows you as a business to potentially take action, to do something about it. There's learnings from consumer expectations in here that allow us as businesses to figure out how to better serve our consumers and to make sure that we're making them feel safe and secure when they're transacting or interacting with us digitally. Now, this is probably one of my favorite ones because I probably should have surveyed all of you before I put this up there, but ultimately, who do consumers think are responsible for fraud? And I probably should have added the age cut to this one, but 61% basically say it's your guys' job, right? As a business, you are responsible to protect their data from being stolen or from fraud. Only 33% felt that it was kind of their responsibility to avoid fraud when digitally interacting. So, I thought this was interesting, but maybe not all that surprising. And, it puts the onus on us as businesses to figure out how to protect consumers. So, one of the things we wanted to look at with the research is, okay, trust is important. That kind of makes sense. The more you trust a business, the more you're willing to do business with them. Fear of fraud does make sense. More and more people are hearing about the data breaches. They potentially experience fraud. They've had friends or relatives that experienced fraud. But then what happens when you start to say, okay, well, are you willing to live with more friction to protect you from fraud? And this is where we kind of get into, really, do consumers understand your side? Do they understand what you guys are trying to do, with potentially ways of identifying their identities, digital identity verification? And quite frankly, a lot of them don't. So about 70, the first three buckets here from left to right, the dark purple, medium purple, and green, they're upwards of about 75% really don't understand what digital identity verification is, and they don't really understand why companies do it. So I thought that was interesting because I think there's an opportunity to help educate the market on why digital identity verification is important, but they don't really understand your side of the business. So what that means is when we are implementing digital identity verification or steps in the process when consumers interact with us online, it equates to frustration for them. And so this is basically how many folks have experienced frustration on a digital platform, interacting on a site by the age cut. And obviously that's a pretty high percentage of folks that feel frustrated during their digital transactions or interactions, and by age cut. And this is probably not too surprising, is that some of the younger generations feel more frustrated than some of the older generations, and some of that just could potentially be patience, or it could be that they actually interact and transact more online than some of the older generations. So what are some of the main causes of their frustration? And really the top three here kind of summarize this. The process took too long. I was asked too many questions, or I had to provide too much information to say who I was or what I was doing. And there were too many separate steps, like too many hoops I had to jump through. So those are all things that businesses, the benefit is we have control over those things, right? There are things we can do, which is why Matt is here to talk more about that, to actually have a positive effect on these three, top frustration causes. So what does it really mean? So digital identity verification frustrations for consumers basically means they're going to leave. So 60% of the respondents said they had abandoned a cart or a transaction or dropped out of an account opening because the process was it just took too long. It was too frustrating for them. That's a pretty large percentage of people that are just willing to walk away. Potentially not that surprising, but that's a big impact, right? To businesses that are obviously trying to bring on more consumers, keep good consumers, having them abandon and go elsewhere is a problem. So ultimately, what is kind of the interplay between friction, trust, and how does that impact revenue? So the next couple slides will kind of walk through that. So 92% of those basically surveyed, they want it all, right? I want a fast, frictionless experience, but I want it to be trustworthy, secure, and as safe as possible, right? So modern consumers, we just want the moon, right? We want all of those things. So that's why it's really challenging, right, for modern businesses. And as these demands grow and as more and more things move online, and like I said before, I really do think the impact of COVID-19, we're going to see, I think we're going to see that increase. I think we're going to see more and more longer term digital interactions take place. And as businesses, we've got to figure out how to provide fast, frictionless experiences that are safe, secure, and protect consumers from fraud. So how do we balance kind of fraud with friction? And really, as DJ mentioned in the beginning, online fraud is increasing. You guys know that. You guys probably live and feel that. I think when we have things like we're having now, any disruption in the market is an invitation for fraudsters to go out and attempt new ways to attack businesses. But ultimately, what does that really mean for your revenue? And the stat on the right is basically shows that when credit card interactions happen in stores physically, there's a 98% acceptance rate, and when they happen digitally, it's an 82% acceptance rate, right? So how do we increase that gap? What does that really mean? Or decrease that gap, that delta? What does that really mean for businesses? And so here's the money slide, right? Is the cost of fraud estimated at about 28 billion, but the cost of potential revenue lost to false declines, to potentially too much friction, to denying good customers, is upwards of 300 billion. So we're talking kind of a 10x change. So really, how do we leverage the data, the demands of the consumer, leverage modern technologies such as machine learning, which Matt's going to talk about, to have a positive effect on all of these things? So why is getting digital identity verification, right? Why are we here talking about this today? And really, it's because of consumers, right? They have choice, and they have little to no patience for a subpar digital experience, and they can go elsewhere. And so how can companies today have behind the scenes improvement in their digital identity verification? How can they leverage additional data, different techniques, different ways to reduce the impact to the consumer by also protecting their business? So I'm going to turn it over to Matt now to talk about the application of machine learning to actually address a lot of these consumer insights we just talked about.
Great, thanks, Beth. Yeah, so as Beth mentioned, there's this conflicting customer expectation that you're both providing this fast, frictionless experience, as well as owning the avoidance of fraud, providing that trustworthy and secure platform. So I'm going to talk a little bit about some practical guidance on how you can leverage machine learning to help meet both of those kind of conflicting expectations. Just looking at the list of attendees, there's folks from all sorts of different backgrounds, and so I thought it would be good to start by kind of laying some foundation and talk about some of the fundamentals of machine learning. So one of the common patterns that I see kind of across the board is folks tend to interchange the usage of artificial intelligence and machine learning, where they're actually two kind of distinct terms. When we talk about artificial intelligence, this is really talking about making computers perform tasks that normally require human intelligence. So think about chatbots that are gating customer service calls, or self-driving cars, or image recognition, or pattern analysis. These are all examples of applications of AI where it's really easy and intuitive for a human to perform the task, but very difficult to program a computer to do so. Machine learning is actually a subset of artificial intelligence, where computers are taught to identify patterns and make predictions without explicit instruction. And delving a little bit deeper, there's two types of machine learning. One is supervised learning. This is kind of the more common type that most folks refer to when they mention machine learning or ML. Supervised learning is good for classification problems or prediction problems. The use case at Ekata is for detecting fraud. I'm sure many of you on the call are leveraging a supervised machine learning model in that use case. But with supervised learning, what you're doing is giving the computer a set of data points or characteristics referred to as features that describe kind of what you're trying to solve for, and labels that enable the computer to analyze all that data and identify patterns such that when it sees new data, it can make a prediction for what you're trying to solve for. An example of this would be creating a supervised model for predicting housing prices. Your features or characteristics would be things like square footage, amenities, proximity to schools, and other such describing characteristics. And your labels would be the sales price or historic sales price of these homes. The model would look at all that data, identify patterns such that when you fed in data about a house that it hadn't trained on, it would be able to hopefully accurately predict the sales price. The other type of machine learning is unsupervised learning. It's called unsupervised because in this case, you're not providing the labels for what the computer's trying to predict. And so what it's really doing is attempting to cluster or group data together based on common patterns or characteristics. And so applications here are anomaly detection. So if a fraudster is doing something that's kind of outside of normal behavioral patterns, unsupervised learning is good for detecting that, as well as pattern analysis on your data to identify areas where your manual review agents or rule systems or models might be missing a trend. So why is machine learning a good tool for improving digital experiences? What we're seeing at Ekata with our customers is that many of our more sophisticated e-commerce partners are building out these dynamic checkout experiences that will apply more or less validation steps based on a risk assessment. And there's kind of two ways that you can go about implementing that risk assessment. One would be a conditional rule system where you're explicitly defining a set of rules. The other would be a machine learning model. While both approaches are good at kind of satisfying the requirement around a fast decision to deliver that kind of seamless user experience, rule systems tend to break down after that if you think about the other needs in this space. First, in terms of scalability, building out a rule system that is robust enough to account for all the various corner cases that you're going to come across can be quite difficult. And as you build out that system, you have to think about the maintainability of that system. I talk to a lot of customers, and there's, it's surprising how many have built up these kind of rule systems, mostly in the fraud application, where they have thousands of rules. The whole system is kind of a black box. They don't really know what's going on, and it just is a very painful and costly to maintain. On the other side of the house, machine learning, you're dealing with a single model that can be retrained and much easier to maintain over time. The other piece of the puzzle is oftentimes you're dealing with data and trying to make a risk assessment where there's no single data point or attribute that's extremely predictive. And so you're relying on the ability to identify complex interplay between different identity or different attributes and identifying different patterns, which can be a challenge to do and maintain. Whereas this is really a strength of machine learning, is looking at vast volumes of data and picking out the finer kind of patterns that are more complex and harder to pick out as a human. To kind of show you guys a proof point, we'll look at the adjacent problem space of the more traditional fraud assessments, where we can see how a simple ML model won out over a complex rule system. So this is from an actual customer. This is real data depicting chargebacks over time. This customer had a fraud problem. Despite having a rule system that they had built up over years, it was complex. They had hundreds of rules, catching all these nuanced scenarios. But despite that, their chargeback volume was much higher than where they needed it to be. And so they decided to invest in an ML model. And you can see on the graph, there's a very dramatic drop-off in chargebacks from introducing this very simple model. They spent a little bit more time just fine-tuning the model, retraining it, and with the introduction of that kind of second version of the model, they were able to bring their chargeback rates back under control. And in the process, they were able to move from this very complex rule system, which was costly to maintain, to a single machine learning model and just a handful of rules to help with routing. So how can we leverage machine learning to provide a world-class digital checkout experience? There's three primary areas that I'm going to focus on today. The first would be how model building for checkout scenarios differs from the more traditional fraud modeling that I know many of you are doing. The second is how model tuning should be approached to ensure that your model is both performant from a prediction standpoint and is meeting your business goals around reducing friction. Finally, some of the challenges with accurately measuring the success of an ML solution in this kind of checkout workflow. We'll start with some of the differences with building models for pre-authorization applications. So this high-level workflow should look familiar. It kind of illustrates the end-to-end checkout process that we typically see with our e-commerce partners. Traditionally, all of the fraud and risk checks in this workflow occur well after checkout. And you have, in most cases, a lot of time to make this, this risk assessment comparatively. Sometimes that's on the order of seconds, all the way up to days, depending on the vertical and that fraud review process. As I mentioned previously, the trend that we're seeing is that more and more customers are moving upstream and beginning to develop models to make risk assessments during the checkout experience and either dial up or dial down that level of identity validation that occurs during that kind of phase of the experience. So when you're considering the opportunity to leverage a model here, there's some constraints and differences to keep in mind. Specifically, your decisioning time is reduced over kind of what is available in the conditional fraud assessments. You're moving from seconds to what we typically hear is anywhere from 250 milliseconds to 500 milliseconds. So you have a lot less time to get the data you need to make a decision. The other piece of the equation is the increased volume. You're seeing much more volume at this point in the workflow, which has implications both on how you engineer your solution, as well as impacting the ROI of sourcing data externally. Before I move on, let's pause here for a little bit of audience participation. I am going to turn it over, I think, to PJ to facilitate this question, but how many of you are currently have your risk modeling focused in the blue area, on that diagram, where you're doing conditional callouts, meaning you're calling external providers to get additional data to help facilitate that risk assessment?
I'm going to give folks a second to answer this, Matt, thanks. And I just wanted to mention that we have had a couple questions come in, and please keep sending them in. We'll get to your questions at the end. We appreciate them. So we're just going to give it a couple more seconds while more people vote. Okay.
Okay, great.
There's how the folks answered.
Oh, wow. Yeah, a lot of folks are moving into the pre-auth space. As I mentioned, a trend that we're definitely seeing among our customers. So let's talk a little bit about how we deal with those constraints. Perfect. So of course, it's essential to identify and leverage as much information as possible, and more importantly, getting as much diverse information as possible that can be gathered within that very constrained SLA or time frame. The more data, of course, the better performing your model will be. What we typically see from our customers is a variety of data, including CRM history, product and SKU data, blacklists for high-risk individuals or product types or other indicators, device fingerprinting, biometrics such as mouse clicks, time to checkout, and other more behavioral patterns, as well as identity data. While much of this can be sourced in-house and is readily available at checkout time, the real kind of exception here is identity data, which often requires external callouts. The issue here is that most external providers won't be able to meet your SLAs and may be cost prohibitive at the higher volume that you're going to see pre-authorization. This is one area where Ekata can help. Our transaction risk API was specifically designed for this scenario and delivers identity verification data in under 100 milliseconds, so it will meet your SLAs, and is designed to be directly fed into a machine learning model. We've had a number of successes here with key partners, including one of the largest global travel companies, which saw a 20 to 25% increase in or improvement in their payment fraud detection rate. we saw a managed e-commerce business with a 5 to 15% performance increase in identifying good customers, depending on the vertical. That's why the kind of large range. And leading marketplace saw a 12% improvement in recall by including our data as part of their pre-authorization ML model. The reason I highlight these kind of data points and successes is it really goes to show that the more diversity in the information that you're training your pre-authorization model on, the better and more performant it'll be. So the next consideration when building a model to improve your digital experience is how you tune your model in alignment with the business problem that you're trying to solve for. So there's a number of ways to measure model performance. Throughout the industry, area under the curve, or AUC, is very common. That's what we use in the majority of cases at Ekata. Other performance metrics you might be using or have heard of include precision and recall, confusion matrices, accuracy, and F1 or F scores. No matter which performance metric you use or set of performance metrics you use, when you're building a model to reduce friction, building the most performant model might not achieve your business goals. Let me explain. So when we look at reducing friction, our key goal is reducing the false positive rate, or the percentage of good customers which receive undue friction during checkout because the model made an incorrect prediction. Therefore, it's really critical to constrain your model such that its false positive rate doesn't exceed the thresholds that are defined by your business needs. This is a strategy we sometimes employ at Ekata, depending on the scenario, where we approach model building by maximizing the predictive power while constraining the false positive rate to a threshold that we set at the beginning of the project. So let's look at a real world example with the charts below. In this scenario, we had a model that returned a numeric score between 0 and 1. And we needed to identify a score cut point or threshold where below that cut point, we indicated that indicated a lower risk, and above that cut point, we indicated a higher risk. Let's look at the chart on the left first, where we're plotting false positive rate across a score range. And we defined our false positive threshold, seen in the kind of purple horizontal line, at 2.5%. And so this helped us define our cut point. This meant that our false positive rate at 2.5% yielded a maximum, or I guess minimum in this case, threshold of somewhere just under 0.96 score. And so now if we turn our attention to the performance chart, in this case, we're using F1 score to measure predictive power of the model. You can see the performance curve. And if we then chart that maximum threshold, just under 0.96, you can see that the intersection point with the performance line is actually less than if we had solely chosen our threshold based on performance. Said another way, if we had purely tuned our model based on performance and hadn't set that threshold for false positive rate, we would have resulted in a product that didn't meet the need because the false positive rate would have been much higher than our acceptable rate. Really, the key takeaway is that false positive rate really should be a key KPI when you're defining your success metrics for your pre-authorization model, not just the more traditional performance metrics that we think of when we're doing model building. And depending on your business needs, it might be a good idea to establish constraints like we sometimes do at Ekata around the false positive rate to ensure that your model is both performant and achieving the desired outcome to reduce customer friction. Okay, so let's spend a little bit of time talking about some of the approaches to measuring success. You built a model, you're going to integrate it into your checkout experience. How do you ensure that it's making a positive difference? This is actually one of the biggest challenges when it comes to improving the checkout experience, whether you're implementing a model or a different solution. You know, in the fraud space, you have very clear, unambiguous signals like chargebacks to help measure whether or not your solutions are successful or not. Here, detecting false positives is much harder as there's no real feedback loop. So let's go over the pros and cons of 3 common approaches that we see in the industry, the first of which is A/B testing. So what this is kind of where you're letting a small percentage of customers through your frictionless checkout experience, putting no additional blockages in place despite what your model is predicting. You then follow those customers over time and you see which ones result in chargebacks or fraud. This yields a very high certainty in measuring false positive rate, but the downside is you're incurring fraud loss. Additionally, these types of solutions can be very difficult to implement. They're typically quite complex to design and implement in a way that doesn't expose yourself to a loophole where fraudsters can just bypass your risk checks. The second method would be a post-mortem review. This is where you're sampling a set of customers that were flagged as high risk, and you follow up with them via a call or survey or another outreach method. This approach forgoes the fraud loss, but is quite labor intensive due to that customer outreach. There's an additional problem too, that it's very hard to tell if a given customer was actually attempting to commit fraud, just because you're really gonna have a hard time reaching those customers. They're probably not going to pick up the phone if they use their real phone number. And if you are able to reach them, it's pretty difficult to distinguish between a real customer that's frustrated and a attempted fraudster. The last approach is similar, but eliminates some of the labor overhead. Here, you're simply waiting for customer complaints and leveraging that data to determine your solution efficacy. The challenge here is similar to post-mortem reviews, but with the added issue of selection bias, whereas the only folks that are going to be calling and complaining are either those customers that are really frustrated with their experience or is a persistent fraudster. And I don't think there's a real good way to tell between the two. Ultimately, the key here is that you have a plan for measuring false positive rate and implementing it. We've seen all 3 of these options implemented successfully with our customers. Oftentimes, monitoring impact is forgotten about or left to the end or assumed to be easy, which can be a huge misstep in the case of building out solutions to improve your digital experience. Now, to wrap up on my section, I kind of want to switch gears and talk about how we leverage machine learning at Ekata to build world-class identity verification solutions, and more importantly, how those solutions are helping our customers improve their digital experiences. As Beth mentioned at the top, at Ekata, we help customers validate digital identities and assess risk based on a customer's inputted name, email address, phone number, physical address, and IP address. Confidence score is kind of our flagship machine learning attribute, which takes all the information that we know about a given identity, including authoritative checks such as the validity of individual elements, match status between different identity elements, as well as a behavioral analysis. We feed all of that information into a gradient-boosted machine learning model and produce a score between 0 and 500. The higher the score, the higher the risk. Lower the score, lower the risk. This is consistently one of the top performing attributes that we provide our customers when they feed it into their ML systems, and has helped hundreds of customers differentiate good customers from bad. In addition to the confidence score, we have what we call our network score, which is a behavioral focused risk score. The network score derives behavioral insights from the millions and millions of transactions we see daily from our over 1,200 participating customers and produces a risk score between 0 and 1. With this attribute alone, customers have seen recall rate improvements up to 14%. Which is huge and indicates the high predictive power of this attribute. And then finally, we produce a variety of proprietary attributes that leverage both authoritative data as well as behavioral data from our network to derive highly predictive signals. By providing these derived features, we're helping our customers reduce the time that they have to spend on feature engineering and just provide highly predictive signals. One example of this is our IP risk flag, which is consistently a top performer when used in a machine learning model. It's effectively just determining what the risk level associated with a given IP address. That, along with network score and confidence score, very consistently are helping our customers increase the performance of their models. And these are just 3 of the 15 highly predictive attributes that we provide in that transaction risk API that can be delivered in under 100 milliseconds for use cases in pre-authorization modeling. And with that, I will turn it back over to Beth to close us out.
Great, thanks, Matt. That's awesome. Just a few kind of key takeaways to summarize what we've been talking today, about today. So obviously the increase in our lives becoming more and more faceless, right? More of a digital interaction and transaction world. Trust will continue to become a cornerstone of for businesses to interact with consumers. Security and data privacy will continue to be important for consumers and for companies. Fraud is still a concern though, right? Because as sophisticated as everything the technology gets for us to have, you know, more things at our fingertips and the ability to do everything in a digital world, it also opens up the door to fraudsters taking advantage of that as well. And then basically, how do we leverage things like machine learning, the data that Matt was speaking about, and figure out how to improve digital identity verification processes behind the scenes to help reduce that friction on our consumers. So we really appreciate all of you joining us today. As DJ said in the beginning, it's a really different world, and you know, I know folks are balancing working from home and caring for their families. Many of you probably have children and you're trying to figure out how to do online schooling, didn't know you were going to be a homeschooler while working full time. So we really, really appreciate you guys spending this time with us, and want to make sure that we leave some time to answer hopefully some of those questions, DJ, that you said had come up.
Yeah, absolutely. So we're still taking questions. So if you want to put one in at any time before we end, please do. If we don't get to your question, somebody will get to you offline after the event. So don't worry about that. We do have a few minutes left to answer live questions though. Beth, there were a couple that went back to the survey results, and they wanted to know, one wanted to know, were any of the consumers that you surveyed ever victims of fraud? So I guess did they break out folks
Yes.
who had been fraud victims as opposed to just
Yes,
generally?
that is an excellent question. And I don't have the full report sitting in front of me, but I know that we did a percentage that had already experienced fraud or had known somebody who had experienced fraud. And I think it was upwards of 30%. But I can make sure we have it actually broken out in a different chart that wasn't particularly in here. So we do have that data broken out in the research, yes.
Okay. And you did say that you were going to make the research available to folks?
Oops, sorry, I just lost my earbud.
Is
yes,
that true?
yes, just lost my earbud. We will make the data. It is available, and it has the full report. And as DJ said, we will actually make sure we answer all of your questions. We like to also do that in writing and send that out to you guys so you have it. So we will also make sure to have thorough vetted answers sent to you in writing after the webinar as well.
Excellent. Another question that came out of your discussion of the data was regarding the delta between card present and card not present authorization rates. What is the percentage of hard declines versus soft declines? Did you have that broken out?
That is an excellent question, and I don't have that in this data, but I can go back and talk to our gentleman that leads our payments vertical. He may have that data. So I will go see if we actually have that and make sure we get that to you if we do.
Fair enough. Absolutely. And this question came in while Matt was going through his explanation. You may have gotten to a little bit, but if even if you did, it's probably good to reiterate. The question asks, if you're deciding pre-auth, how would you even know there's a problem unless you're getting blown up with customer calls? Won't most people just move on without you knowing it?
Yeah, that's a great question. And, it's, as I kind of spoke to, it's really difficult to measure success and how big your problem is. The most definitive approach is likely going to be a combination of tracking customer journeys and letting some customers through, as well as those follow-ups for customers that either were, received higher friction or maybe left their checkout experience through some sort of outreach. You're not going to get super definitive data here, but some data is better than none.
Perfect. Here's a question that asks, how often does your team see significant changes in fraud patterns or score distribution shifts within your models? And does the current COVID-19 environment change how your teams are training or building the next model iterations?
Yeah, that's a really good question. We are constantly monitoring our models to see how scores are shifting, depending on different trends that are occurring. One of the things that we do as we're designing features is trying to design them in a manner that accounts for trends. Prior to COVID-19, one of the big ones for us was Black Friday. And we build up features that try to accommodate scenarios like that, where we might see elevated rates of velocities across the board, and account for that when considering an individual's velocity and how it relates to the kind of rest of the environment or situation at hand.
And I just also want to add to that. We are currently doing analysis on current data, because one of the things that we do want to be able to put out and share with our customers is was there hard evidence of impact to the data and patterns for COVID-19? And obviously we don't necessarily have exactly enough data yet, but that's something that we're looking to actually put out in June. So stay tuned for that. Excellent question.
Okay, we'll take one more because we're coming up to about 5 minutes before the hour. Give folks a few minutes to get ready for whatever they have coming up next. But the last question is, I already have a set of rules that I use during checkout. Do you look at machine learning as a replacement to that or as an addition to that?
Yeah, that's another really good question. What we see a lot of folks doing as they kind of move down this evolution from rule systems to modeling is that there's really a place for both. A common strategy that I see employed is a kind of combination of models and rules. Some customers have a couple of different models and they'll leverage rules to do some routing. Another really good application of rules is to react very quickly to emerging trends. So a strategy that I see employed fairly often with high degrees of success is having more senior manual review agents kind of monitoring macro trends and recommending rules based on things that might not be captured by your model. Because sometimes there's emerging patterns that are hard to react to quickly in terms of retraining a model. And so leveraging rules as kind of that mechanism for a fast response to emerging trends.
All right. Well, I want to thank Beth and Matt. It was a great presentation, and as Beth said, things are really weird now, and we appreciate that people took any time at all to to come and listen to us, but many of you did, and many of you hung in the entire time. So thank you so much. As I mentioned, there is a recording of this that will be available on Card Not Present. As Beth mentioned, they will be getting out the research to folks who signed up for the webinar. And again, thank you so much, Beth and Matt. Thank you too, and we will see you next time.
Yeah, great. Thank you for having us.
Yeah, thank you for having us. Thank you, everyone.